What's up, guys? Welcome back. Patrick here. Moving on to the next question. We got the limit as x approaches infinity of the square root of 9x squared plus 5x minus 3x. So if you notice, this is a type of limit that we've already covered before in previous sections. We covered it in the limits at infinity section. But in that section, we didn't really discuss the type of form that it's in. And since we're talking about different indeterminate forms in this section, thought I would bring back a limit in this format so we could be a little bit more conscious of the type of indeterminate form that it is initially presented in. So if we do a direct substitution, what we're going to get here is, notice that if we plug in a very large number, infinity, for these x values, we're going to get a very large number here. And then the square root of a very large number is still going to be a very large number. So this is going to be positive infinity here. Then we're going to have minus, and then notice 3 times infinity is going to be infinity as well. And so notice that this limit in particular is an indeterminate difference, right? So I haven't mentioned that when we covered limits like this in the previous sections, but the type of form it's in is an indeterminate difference. So just want to make you conscious of that. But the way we're going to solve this limit is the exact same process that we've covered before. Notice that we're going to have to rationalize this. So what we would do is we would multiply this by its conjugate. So it's going to be 9x squared plus 5x. But then this middle sign we're going to change to a positive. All over the square root of 9x squared plus 5x plus 3x, like that. So it's like we're taking this expression, multiplying it by 1. And so what's going to happen now, let's actually write it over here, is the top is going to be, you just multiply the n, so the square root of this times the square root of that is just whatever under that square root. Then we're going to have minus 3x times positive 3x is negative 9x squared. All over, this is basically all over 1, so we're going to be multiplying it by that expression right there. So we're going to have the square root of 9x squared plus 5x plus 3x. Now notice in the numerator, the 9x squares are going to cancel out. So what's going to happen is we're going to have the limit as x approaches infinity of 5x all over the square root of 9x squared plus 5x plus 3x. Now, notice we're dealing with a limit at infinity, and what we want to do is basically divide everything by x to the power of the highest exponent in the denominator. So what I'm first going to do, like we did in that section, is I'm going to take this square root of 9x squared plus 5x, and I'm going to rewrite it in a certain format so we can know what the degree of this is here. So what I'm going to do is factor out the highest exponent, x squared. So we'd have 9 plus 5 over x. And then this is going to be the square root of x squared, the square root of 9 plus 5 over x. And then this would be x. Like that. So instead of writing this, I'm going to write this. Both of them are the same thing. And now we could tell what we have to divide everything by. Notice we got x to the power 1 here in this expression, then x to the power 1 in that expression. So that's the highest exponent. So we would divide everything by x to the power of 1. Another way you can do this is you could factor out an x from both of these expressions, and then that x you factored out would cancel out with this x. So whichever way you go about it, what you're going to end up with is 5 over the square root of 9 plus 5 over x plus 3. Right? Whichever method you go through, this is what you should end up with. And now notice we can sub in this x value of positive infinity here. 5 over infinity would be 0. That's going to go towards 0. So we would end up with 5 over the square root of 9 plus 3. Square root of 9 is 3, plus 3 is 6. So 5 over 6 is the final answer. Okay, so this is more so a review right? We've covered this type of limit before, but just kind of wanted to make you conscious of the type of form that it is initially in. It's an indeterminate difference.